work once already. Okay, so we'll start with this silly little worksheet that explains kind of like what we're doing today, at least gives them a little solid base to what we're doing today. Up on the student stuff. Okay, can you or can't you do what's called the 7 bridges of Knigsberg question? And then from that, can you or can't you make these drawings without lifting your pencil once? Then after that, from those graphs, number the odd degree, or how many odd degree vertices are in a drawing, and how many even degree vertices are there in a drawing. Which ones were yes, which ones were no, and then make an extrapolation for that. Back up to this. Pay attention, pay attention, pay attention. In this particular drawing, everything is a vertice. So when we look at this, these are all vertices. Nothing goes over or under something else. 2, 3, 4, 5, 6, 7. There's like 8 vertices in F, right? 1, 2, 3, 4, 5, 6, 7. I double counted one. Mistake on the line already. I will ask you to, kind of stop working when we're really ready to go. You should got to know on this. I go this way maybe, then I go all the way across maybe, then I go over here and I go across this way, and this way. Well, that's because I'm standing in your way. And then at this point it falls apart, because then if I go over here, I have only one of 2 choices. Then after I make that choice, I'd have to reuse a bridge in order to try to get that last one used. You try this whole bunch of different ways, and you get a no on this. Remind me to go back and graph this, put this in graph form, put together after what we extrapolate what maybe the reason is, even though it's not going to be fully clear, because it's just going to end up being an idea, a theorem or whatever. And I'm not going to go like this to fit this in here. I'm not going to go page back and forth. I'm going to get dizzy by doing that. So what I'm going to do is do what all the directions say right here, and I'm just going to put the even degrees and the odd degrees right next to each drawing, the number of and the number of. And then we'll talk about what the extrapolation would have been, and if you got the extrapolation, that's great. But you're not going to get fully, because there's only a couple of examples. But hopefully at least made some comparisons, and see if you did get this right or not. But first of all, if I start here, of course I could draw this without ever picking up my pen, and I did not actually call this what I should have in the other hour. What is it called when I start at a vertex and use every edge once and end at the same one? That's a Euler or Euler circuit. You said it. I just wanted to make sure we knew that. Now, what's the degree of each one of these? There's 2 edges coming from each one of these vertexes or vertices. So there's 3 even degrees and no odd degrees. That's what you should have put in your chart off, up at the top. Now we're good. Next one, I don't care where you start. I start here, go, and then it doesn't matter which way you go. If I go this way, then I have to go that way, and then have to go that way, and I end here. First of all, is that a circuit? Yes or no? Yeah. No, because I didn't end where I started. Sorry. But it's actually called a what? Euler. It's a Euler path. You use every edge once, and you end at a different vertex, not the same one. Okay, now, it does say to do this. Circle the odds, because what are both of those degrees? What number specifically? 3. I have 3 edges coming from that vertex. But what are these? Those are 2. So I have 2 even and 2 odd. All right, I'll wait on that. Could we do letter C, yes or no? No, I don't care what you did. If I do the square first, though, then I'm left with one diagonal, and I would have to use an edge again. So that other diagonal doesn't get to be used. Okay, I'm going to do this on purpose, because what's the degree of each 4 of these corners? What is the actual degree of those? 3. What's this degree in the middle? It actually is 4. We are counting that as a vertex, so I have 4 different paths from that. So I have 1 even, 4 odd. Now, letter D, I could have started here, Lost my pen. And then went this way, this way, this way. I want to make a point of this. I think I didn't make that point so clear and go back to this when we went to our notes. Does this work when I do this? Yes or no? Is that a path? No, but I could have done something different. And that's actually something for what's going to happen with this specific type of situation. If I start here, then I'm good to go. Because then I could use that bridge across. That is a bridge, by the way, right? Connects these two, which are rotated squares, what some people call a diamond. So basically, I should be circling these that are yes, and then crossing out the ones that are no. Yes, no, yes, no. That's a yes. Okay, what are all of these degrees? I don't have them circled. Those are all even. They're all 2. So there's 6 even. And then what is this? 2. 2 odd. Interesting. Or not. Can we do E? Yes or no? Boy, I really jacked up E. I did it the worst possible way. Maybe I'll try to square on the outside. Then I'll try to bridge to the square on the inside. And then I'm in real trouble now. I'm in a lot of trouble. Because now I think something similar happened with the other hour. No matter how many times you try on this, you're going to get a failure. What are all of these degrees on the outside? What are all of these degrees on the inside? So how many evens do you have? I don't have any. Me? How many odd degrees do we have? You guys forget how to count? It's 8. Now, how many people got a yes on F on their own? All right. Now, there's a yes on F. Watch what I do. And it actually pertains to what I did on this one, too. Look at the circles. It failed when I started here. But when I started here, I ended here. Yeah. Okay, what's the degree of this vertex, everybody? 5. What's the degree of this vertex, everybody? 3. What are the degrees of the other vertices, everybody? 2 or 4. So I have 2 odd and 1, 2, 3, 4, 5 even. Now, you could have went anywhere other than where I'm going to start. If you would have started anywhere other than this vertex or this vertex, you got to fail. Now I got to be careful. I'm going to do this little loop around once. Maybe I'll get rid of this corner next. Corner, corner. I'm getting nervous now. I'm getting real nervous. Maybe this one. This one is completely different than what I did the other hour. This one. This one. Okay, I feel good now. This one. This one. This one. This one. I used every edge once. That is not the only way you could have done this. Like I said, what I did 6 hours was something completely different. So, look at this. How many odd degrees are there? Again, how many? 2. 2. 2. And what are they? Yes or no is for paths. Yes, Mr. Samuelus. All right, is this a yes or a no? This is a yes or no? Yes. I think what's smart is to go on the inside first. And then go on the outside. Hey, by the way, what did I end up getting? Was that just a simple path, or what was that? That was an Euler circuit. That was a yes. What are all of these degrees? Starts with an E. I don't have the time for this. Even. Is that 8 even and 0 odd? Right? You okay over there? How's that come? Good? And then the last one, star it, and then pentagon it. Hey, by the way, what is this? An Euler circuit. What are all of these degrees? What are all of them? Even. How many are there? I think they're fading out on a Monday. How many did you get? 10? But no odds. So the extrapolation on the other side should have been this. Every time I had no odds, I was able to make a circuit happen. Now, you probably didn't get that. You didn't write the word circuit. But you could at least said it worked, meaning I could use every edge only once, and that would get, get it done. And then what's unique All the ones that have odd Q degree exactly. As long as you trial and errored and tried a couple times, you would have got a successful what, though? A circuit or a path, Euler? Path. Someone's with me. Someone's listening. All right? What I told you to tell me to do is graph this. So I'm just going to do this by looking at A. How many different paths to A from A to B? No, from A to B. 2. I don't know if I want to draw this way. So I'm going to try to graph this, then use the idea that we just did, why this doesn't work. So this is why you get a line here and a line here. That just demonstrates there's two different ways to get from A to B. Who is B connected to other than A? B is connected to who? D. So I'll put D over here. Doesn't have to look like the picture. What it has to look like is how many ways can I get from B to D, and it's just one. But who else can D get to? A. And who else can D get to? C. So now I introduce C over here. And I draw a line from D to C, and there's only one way to get from D to C. How many ways can C get to A? 1, 2. So this is how you put it in graphical format, just to count how many ways we can get to this. What's the degree of this right here? What's the degree of that? 3. What's the degree of this? They can't count. 5. What's the degree of this? 1, 2, 4. What? 3. What's the degree of that? 3. And then what's this one? 1, 7, 3. So all of these are what? I don't know. No one can count apparently. All these are what? Odd. How many odd degrees are there? Odd. So the rule is going to be this. Here now comes the notes. Oh, I can't wait for the students to be so excited. Ta-da! Okay. Euler's theorem. If a graph has, you ready for this? Ow, she kicked me. Violence from a student. If the graph has no vertices with odd degree, then it has at least one Euler circuit. Euler. I think it's actually pronounced Euler, or it depends on the person. I don't really know. Then the next thing, which only happened 3 times. Alright, so from you having 3 successes, we're going to make it a theorem which makes it true all the time. At least you've seen it 3 times if you were able to get the 6. How many people successfully got that one? What did I say again? That one letter all by yourself? What was it? F? F was the first unique one. You got it by yourself, that's good. And then, blah, 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 blah. The graph has exactly, no more, no less, 2 vertices with odd degree, then it has one Euler path, but no circuits. But the Euler path has to start at the odd degree vertex, 1 of. Otherwise it won't work. That's why you got a failure at first. Just like if you have all even degrees, not everything would be a circuit depending how you start it. Not every way that you decide to travel. So you do have to follow some rules. This Fleury's algorithm, I am going to explain it, but you can avoid it. But I am going to explain it. It was kind of weird to me what's going on with it, and I know it would definitely be weird for you. And then just to jump back, I know this is in the middle. This drawing should be after number 3. Just to write that last sentence, if the graph has more than 2 odd degrees, you have no path, no Euler path, no Euler circuit, no nothing special. That was like the bridge problem. You had 4 odd vertices. And we saw we could not use every edge once or use every bridge exactly once and use them all at the same time. I said a little weird. I know what I wanted to say, but okay, I'm going to start blabbering. As you're writing this down, what you should do is make sure you understand what degrees you're dealing with. What's the degree specifically of A? 2. There's 2 lines coming from it. You can't figure that out. Yeah, this is too hard. Baloney. There's 2 lines coming from me. Figure it out. Wow, is he rude? What's B? 3. Star it, my friends, if I can call you that. What's C's degree? What's C's degree? 5. I have 1 student whispering in the background. Star it, my friends, if I might call you that. What's D's degree? Oh, sorry, whisperer. It's 4. What's E's degree? This is a tough one. 2. We got a new player. Let's feel live. F. Which will be your grade if you're not looking at this. 4. Can we have a circuit? Yes or no? Euler circuit. Yes, no. The answer is no. It's taking too long. Can you have an Euler path?
Yeah.
Yes. Monday. Now, for us to have an Euler path, we'd have to start where, though? Where would we have to start? Either at, for the love of dog, name a letter that has a star by it. B, and end at what? C, or start at C and what? End at B. Now, this one's done and closed. Now, I'm going to emulate what you have to do on this for, like, when they ask you to, show me the path. Ooh. Okay? So, I think in the other hour, I started with B. I'm going to go ahead and do that. Now, what you're going to have to do in your homework is the following. If you're going to have to show the path, you have to show the vertice order, but you're also going to have to, on your drawings on your paper, show numbers. Now, I'm telling you, there's a whole bunch of different ways this could go. And before I continue, are these vertices now? Yes or no? All those ones that I've circled in there. No, so it's a little different than what I had you do on the worksheet. I told you in the worksheet all intersections were vertices. So we're not going to worry about those. Those we can go right through. And we're not going to have a problem. So here we go. Now, what I want you to do is pick a way to go and show the arrow. Which way do I go, from B to A or A to B? And call that move 1. This is what you're going to have to do in your homework. So do it now. Now, what do I have to end at? I have to end at what letter? Now, I could have started B to C, because C has a whole bunch of paths to end up at, but what I want to do is avoid it as much as I can. All right, because I need to end at C. It's got to be my last move. So if you have that in your idea, you may not need Fleury's algorithm. You really don't. But I will try to emulate it. All right, so that's 1, and then probably have to go here, so that's 2. I'm going to stay on the outside. That's 3. Now I get a little scared. I am going to have to go up to C and kill one of its one of its edges. I'm going to call that 4. And I'm going to have to burn another one. 5. Let's say I go this way. When you have to do this in your homework, you have to understand everyone's answer could be a little different. Okay, but you got to make sure you use every edge. How much? Once. So you don't reuse them. Ooh, did I screw up? No, I didn't, because I have this little extra one. So I better, okay, no, I'm fine, because I have this one and this one. 2 different ways to get from C to D and D to C. So now I have options. Okay, I can go here, and actually I can't screw up any way I go on this. Because then I could go here, which is 8. Then I could go here, which is 9. And then sure enough, I end up at what? C, which is 10. And then what you would do next is label the vertices. Remember, that's how you designate a path. The vertices that you do. And I'll do it on the last example, but it went, all you have to do is follow your numbers now. B, A, F, E, C, where's 5? B, where's 6? D, where's 7? Oh, I went this way. C, where's 8? D, I'm going in circles. 9, F, 10, C. And that's how you'd label the path. There is a whole bunch of different answers for this. I'm going to have a what when I'm done looking at your stuff? Headache. An aneurysm. I'm going to start convulsing. All right, I'm going to try to emulate this, but really, we just practice that. Not really. You could go around and find a path just by looking at it a couple times and making sure you end at the odd degree. Start at an odd and end at an odd. For all even degrees, following this would be a good idea as well to find the circuits. But I think through what you did there on that worksheet, you can also find it by just being careful. I don't know how else to say it. This works, but its wording is a little strange, and you really won't be able to do what this is saying. And I was just say that right now. So copy the original. So I guess what you could do on your paper is copy the original on your paper. And then when I get to step 4, removing, whenever you use an edge from the original, you erase it. That would be removing it. That would be the only way you could truly emulate this thing. But I think it's a little overdone. I just did it on the previous example, and I had a path that worked. I'm done with that question. So copy the original. Make a graph of the vertices only. So this is step 2. So I have a picture. Yeah, this is it. I have a dot, 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 and it goes like this. All right? And then over here, I'd make just the vertices, equal spacing. Then step 3, choose a starting vertex. Okay, I start here. Look at the edges connected to the vertex. Remove one and transfer it to the other side. So I would have to erase that and move that over here. That's what they're trying to say, and I'll try to emulate this in the actual example. To the other graph and then number it. So that would be move number 1. I do want an arrow. Which way did I go? This to this or this to this? I don't know by when you put 2 which way you went, but I guess it's nice to have that. Now here's the kicker. Do not choose a bridge unless it's the only option left, which should be the last option. So what's a bridge connect? 2 disconnected graphs, or the graph and a separate point all by itself. As long as you avoid that, your path will happen as long as it will have a path. 2 odd degrees only. Repeat until all edges are done. So this is up to you. You can survive without this. That's what I'm trying to tell you. Your job is you will have to complete a path and number it correctly. You probably could do it by a little bit of trial and error, but this solidifies it. Now I will tell you this is a number in your homework. So when you get to that number, this picture is in your homework, and you're asked to show the path and make it happen. So this is what we mean. And I don't know if you're realistically going to do this or not. If you want to, fine. You could do these without that. You could actually look at the picture in the book. So you're just looking at this. That's your eyeballs. And then you can go ahead and start drawing the picture and numbering the sides. And then making sure it happened. Or you could draw it and then just trace over it and make sure that you have a path that's legal. That you use every edge once. Or you literally use the Fleury's algorithm. Now as we're drawing this, you can do 2 things at once. What's A's vertex degree? Oh, 5. Star it, dudes. What's B's degree? Oh no, how many more odds can we have for if this is a path? None. So what's C's degree? 4. 1, 2, 3, 4. Just counting. D. Just counting. What's E's degree? What's F's degree? Just counting. I love you. You love me. We're a big happy family. Is that how it said? So this is the last time we did that kind of math. Just counting, right? When you're watching the dinosaur. Is that the dinosaur? Barney. Didn't Barney teach us math? Counting? Let's continue. Okay, now, what does that mean? Who do we have to start or else we're going to screw up? We either have to start at B or A. So I'm going to make this different than the other hour, because the other hour I started at A. So I'm going to start at B. Whoa. Okay, now, I'm going to go from B to A, so I would want an arrow for that. Now, here's what Fleury's algorithm says. Now remove that. Now, are you going to be able to do that in the homework? Only if you drew it once, and then drew the vertices, and then erased that side. Then we can get this activated. Then you know what? I'm going to go A to F. For here, though, all you really have to do is number this as 1 move, and then this is the number 2 move. I guess I don't really need the arrow, because obviously if 1's there and then 2's there, I know which direction you're going. Does that make sense? Okay, and then I'm going to go to 3, which is, I'll just do FE, I guess. So I'll do FE as 3. Kind of like, I feel comfortable doing the outer edges first. Now, here's where we have a problem, Houston. No, we don't. I'm going to screw myself up because I changed the game. If I go E to D, because that is not a bridge of any kind, doesn't show a disconnected graph, then C to D, so I'm going to go ahead and number those, 4 and 5. And I don't think you really need to do the erasing part now actually to emulate this. Now, can I go from B or C to B, yes or no? No, you could, because that's not a bridge. It doesn't, like, this is still connected. I really think you can go from here to here, can't you? We're not ending at B. Where do we have to end? We have to end at A, right? So we should be all right here. All right, so again, this is why I think this could work in multiple ways. Now, it looks weird that I erased that. I forgot to draw it here. This is a 6. Okay, where do I have to go now? I have to go to E. Okay, so that's going to go here. That's 7. This gets a little crazy because we're going to have some intersections here. And then I have to go to A. Are we okay there? So that's E to A. Then we're going to get where a bridge is going to happen where we're not allowed to go. I think it's coming up. This is 8. It's kind of hard to write the things here. Now what I can't do, I guess could never really happen. Now I'm at A, right? So I'm going to go and I just have to finish this off. I could go many different ways here. I could go 1, 2, 3, 4. Those aren't the numbers. The numbers are different. I really can't get a bridge. The way I did this was actually pretty good. That I didn't end up with a bridge. Okay, so I'm just going to finish it off that I go here, 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 here. So that's why the erasing method, I don't know. C, or A to C, which is 9. C to F, which is 10. F to D, which is 11. And then D to A, which is 12, and I ended where I started. Then what you have to do is tell me your path. So I went B to A. Now all I have to do is find, what was after A? F, what was after F? E, what was after E? Oh, that E just got a little extra thing on it. What was after E? Huh? D? C? No, good. What's after D? C, they're whispering. D's, C's, and B's all sound the same. What's after C? B, then what's after that? E. What's after E? Finally, A is different sounding. What's after A? C. What's after C? F. What's after F? D. What's after D? A. This is but one path that would make a Euler path. Ah. Okay, so that's what you have to answer at the end. Can you imagine me having to grade that? Because how many different answers could there be? A whole bunch.